Yes, test 2 is Tuesday, I believe. I mean, I can double check on that for you guys if you want. Let's see here. This is section 8, right? And in course content, I put a revised course planner, right? So today is quiz 2 and review. And then the 6th is test 2. And we talk a little bit about quadratic functions and models once test 2 is done. Or we can talk about it before. What do you guys prefer? Do you prefer to have me talk before the test or after the test? After? All right. So that's that. Let me get back into the... So, of course, I think, so quiz 3, like I said, I will post the solution to quiz 3 tomorrow. And I'll try to send you an announcement about that once that happens, okay? And, but essentially, quiz 3 involved problems like your homework, right? I mean, there wasn't, I don't think, anything particularly new, for the most part. If you say if you did the homework, well, yeah, I mean, given there's no way I can make you do the homework, right? I mean, it's not a prison camp or something. Like, I can't, like, force you by, some sort of draconian measure. We just have grades. Eventually, there's that. But, I mean, it would be an interesting experiment is if every class you had to, like, wear a little shock thing, and then you get asked questions, and if you can't answer correctly, you, like, get shocked, But you can catch you here? Would make it? You'd be dead. But apparently that's unethical, so, like, we don't do that. But anyway, so this one, let me try to make it bigger. I can't quite read that. Well, actually, before I dive into anything, is there a particular problem in the Mission 3 homework you'd like to talk about? Something that was... Just go over all of it? Well, that I can do. You're going to say what? The next page? Okay. So I'll go quickly through this one then. So this one, basically, the numerator, we need 2 plus x positive, or 0. And the denominator, we need x not equal to 3. So you put those two things together, you get minus 2 to 3, and then 3 to infinity. For this one, the numerator doesn't do anything to you, but the denominator forces you to have x larger than a half. And so the answer is 1/2 to infinity. The difference quotient, I had a typo in this homework. I'm sorry about that. If you did it f of a minus f of a plus h over h, I will not take off a point. That's just a typo. But I did it for the correct thing, okay? And so if you did it right, you should have gotten minus 6a minus 3h if you started with my, typo version, or you would get 6a plus 3h once you simplify. Now, if you got to like here and then you didn't simplify, I mean, I'm still going to give you partial credit, obviously, but, that's basically how you do it. Just evaluate and simplify. What always happens with these problems is there'll be an h that doesn't cancel from the difference upstairs, and that will cancel with the h downstairs. Like, that happens in every one of these problems. That h in the denominator of the difference quotient will cancel out.
So if we simplify that, well, just take out a 30, would that still be right?
Oh, yeah. Yeah, sure. Yeah, I mean, my answer would be improved if I had factored a 3 out. Absolutely. Like, this would be better if I'd written 3 times 2a plus h. If you wrote that, that's even better. What are you asking? Is that what you're asking? Okay. So here's the next one. And so I write 1 over h out front to make it easier to look at. And then I make a common denominator. So to make a common denominator, I multiply the a plus h plus 1 by a plus 1. And I multiply the a plus 1 by a plus h plus 1. So see that there and that there. And then when you multiply these things out, you get a squared plus a plus h minus a squared minus ah minus a. And almost everything here cancels, except for that lonely h in the middle. They cancel, and you're left with 1 over the product of a plus h plus 1 with a plus 1. Oh, any questions? I mean, this one's kind of, like, this one's tougher, right? Part B is harder than part A. Which one did I put on the quiz? Which one did I put on the quiz? Kind of like part A, right? So what would likely be on the test then? A. Evan says A. But I do, as I think about students taking my test, I do assume students are looking at the solution to the quiz, but also the solution to the homework, right? So. That's that's possible. It's also possible part B or something like it is on the test. Let's see here. You guys can do it. You can do it. Says me. Let's see here. Did I hear? Now wait, hold on a sec.
We put 0 for D.
Now
Is that the same thing?
now hold on just a second. Which one did the tutor disagree with?
No, I see what I mean.
Which one did the tutor disagree with?
We did it, but we still got it wrong.
I didn't have this problem on the. No, you could have worked with this in the homework, right? So, which part did the tutor think was otherwise? I'm just curious. The second one? So, the range is the set of outputs. So, the lowest output here is -6. And then you have outputs, well, this, all the way up to 6 here, right? Not included. But you look over here, the outputs here go from 6 all the way up to 8. So range is the set of possible outputs. Outputs are y, inputs are x. Oh, you thought that went on and on? That's a reasonable, do you put infinity too? I could accept that, like that's okay. I would, but as a point of order in here, like I will put, first of all, it would be better if I had put dots. All right, sorry I haven't done that. You can ask me about that in the test or quiz. Well, not anymore, unless you can time travel. Yep.
What does D and E mean?
Does not exist.
Okay,
You can put not applicable if you like.
can I put 0?
0 won't work because 0 will be something. Like the function 0 here, function 0 here, the function 0 here.
What if we meant to put a 0 with the little line?
0.
Does that count?
I'll give you 0 points for that.
But that's not the same thing as
See what I did there? Yeah, sorry.
0 with the line.
No. Anyway, so I hope you guys know from the grading of the first quiz, if you took the quiz today, you're not going to get
A 0.
a representative score of where you are in the material, right? I give generous quiz grading, right? Believe it or not. But I do want us to take a moment to appreciate like why that was not 0, right? It doesn't exist because 3 is not, right? There's no x. When we look at x equals to 3, the function doesn't tell us anything, right? I mean, 3 is not in the, between 2 and 4, not included. I mean, 2 and 4 included are not in the, I mean, going from 2 all the way over to 4, we have no information about the function. So since this is the only thing we know, we assume that the function's not defined there. But yeah, if your tutor thought it was infinity, that's a reasonable interpretation, given like other customs in math books. But since my graph goes on to here, like if I wanted it to go to infinity, I would have drawn the line all the way to the edge of like what's going on. And I'll try to put like an arrow on that if I actually want one to go to infinity. Just so we can be clear in here, if I mean it to go to infinity, I'm going to put an arrow on it. Like draw a little, you know. All right. 27. You know. So well, yours might look a little bit different, but I mean, I tried to be careful as I can be. It should always be the case. Uh-oh.
I mean, I left it blank, so that should be some credit right there. I didn't mess it up.
See, I did not put this on the quiz because I don't want to grade it on your quiz. Why did I do it? Because it's part of the course. That's part of the material.
I'm not gonna know how to. I'm not gonna have to know.
There are some good, some helpful guides. If you're adding two functions, in this case we're adding the blue and the green. If one of the functions is 0, then the graph of the sum has to just be the one that's non-zero. Like here, see that blue one's 0, so green plus blue is just on the green. Over here, blue is 0, so green plus blue is just the green. And over here, green is 0, so green plus blue is just the blue. But generally speaking, you take whatever the value is on the green, whatever the value is on the blue, add them together, that's the red. So like here is 2 plus minus 4 is minus 2. Another example, this one over here. The blue is about 2.5, the green is about minus 1. So 2.5 minus 1 is about 1.5, which is about where this is. So it's just always, you just add the values of the green and the blue together, it gives you the red. It's not just that, yeah.
Have you ever had to use this in a real life scenario?
Yeah, I mean, this is the superposition. I told you guys about the noise canceling headphones. This is the principle of noise canceling headphones, constructive interference.
Exactly.
You guys like sunglasses? Or how about like reflective coverings on windows and cars? These are all based on like, destructive interference, like lightweight. The reflective wave adds with the other reflective wave to cancel out. That's this. It's adding functions. It's superposition. And wait a minute. I'm being far too esoteric. Are you people? Are you humans? You feel like a robot? Do you exist? I think you should agree. I think you should agree that you exist. Otherwise, we can't have this conversation. I refuse to have a conversation with people who don't acknowledge their existence. So since you exist and you just took the quiz, I submit to you that's a real world problem. Well, you just did your homework, rather, I should say. So you did it in the real world. That's a real world application right there. Why do students always reject their own doing of homework as a real world application? I don't understand. All right. Now this one here, I kind of gave you guys a nice shortcut to doing this problem last class, right? I told you about remember, I told you about that quadratic, remember the quadratic vertex formula? Yep. Yeah? No, I'm just showing you how to be careful if you want to be. Like, if you had a picture that looked kind of sort of like this, I'm going to give you full credit. Yeah? So. $29. Yep. So we go from -6 to 0. And then from 0 to 3, and there it is. I don't know. I mean, I had ignored the instructions and graphed this thing all the way over to here, and this one all the way up to here. You can kind of see it. But I whited it out because I went back and read the terms and condition here. minus 6 to 0, and then 0 to 3. What? You hate it? Don't hate your life.
I didn't.
It's
Until this semester.
it's just
Crazy.
it's just math. It is not going to hurt you. It will. You're like it's already hurting. Oh, dang it.
Oh, we're not gonna raise them? That's what he said.
Everybody is 100s.
Everyone.
I'll turn the camera off. We can talk about this.
Everyone. Okay, so for this one, f of minus 2, we have to use the first formula, which I have now not projecting, but the first formula was minus 2x minus 6, right? So minus 2 gives me 4. 4 minus 6 is minus 2. And f of 2, I use the 1/4 x squared plus 2 formula because it's in that case. And so that works out to 4 over 4, which is 1. 1 plus 2 is 3. So. How about this one?
I wrote down like half of that answer.
You wrote down half of that answer? So there's a local maximum here and here, right? A local minimum there. It's increasing all the way to there, right? So it's increasing from like minus infinity to whatever that is. I said minus 6.8. You could have said minus 7. It's debatable. It's fine. And it's decreasing from about minus 6.8 to, I think, minus 2. And then it's decreasing again here from 4 to infinity. So that's why I wrote that. Increasing was, well, minus 2 to 4 also. So
Use whole numbers, is that okay?
yeah, it's fine.
And I didn't write out the local maximum. I just like
Drew a dot on it? Yeah, well, that's probably going to be okay. I really just want you guys to be aware of the concept. So. So I just said, sketch the graph so your graph doesn't have to look like mine. I mean, but it should kind of vaguely look like mine in the sense that it should have, you know. Now, yeah, what if I change this problem just a little bit? Like, what if I had an x plus 2 squared here? How would that change things? Then it would bounce, right? Like, I did one of those in class, right? Okay. So this was nearly on your quiz. It almost made the cut. So, like, odds of a problem like this being on your test, they're pretty high. What's that? If you didn't what?
She didn't make the cut for the quiz, how to make the cut for the test?
Well, I don't make the quiz exactly the same as the test. I mean, if there's like a problem you guys all get right on the quiz, I have to take that off because there's no point in testing that. Well, my advisor, one of the fundamental lessons. I mean, one of the fundamental lessons my advisor taught me was that if you're not taking off points, it's not grading.
So you're testing us on stuff that we don't know how to do, basically.
That's right. I want you to get better. I want you to get better at what you don't know. No?
Setting us up for failure. That's what you're doing.
Setting you up for failure.
Yes.
Nah. Seriously, though, that last problem is a pretty likely test question. Something like it. Problem 32. Now, this one here, I got minus 5 and 4 for the average rate of change from minus 3 to minus 2. The math is here. The 3's cancel. You end up with 4 minus 9, which is minus 5. The other one, you end up with 9 minus 1, which is 8, and you get 2 in the denominator, so that ends up being 4. And I think that makes sense because if we graph it, you can see that it's a parabola that opens upward, and it's decreasing where the rate of change is negative, and it's increasing where the rate of change is positive. So that seems like a natural thing to see.
You said these are already on board?
This is not on Blackboard yet, but I will post it soon. Yeah, I'll try to post this after class once I get. I should post this soon. I'll post the quiz solution tomorrow. So here, you got 10 minus 4, 21, 3/7, 0, and 10.
What is the
E and F, this is the composition. Yeah, you should work on this. This is a big part of the test.
out of a number? That's what I'm not understanding.
How do you pull numbers out of a number? Well, sure. F composed with G of 2 means F of G of 2. This is the definition of that funny looking circle. That's the composition of F with G. So we plug in G of 2 into F. G of 2 is 7. So F of 7 is 0.
They already on.
So in contrast, these last two, right? It's not just addition, multiplication, adding, subtracting, anything like that. You actually have to think through the composition of the functions. It's not just multiplying numbers like, or adding or subtracting like these guys. Yes. Yeah. So here's the, like F plus G of 2 is F of 2 plus G of 2. That's the definition of the sum. And F minus G, that's a new function. It's defined to be F of 2 minus G of 2. Like the difference. Right. Well, I mean, what did you guys get? What you guys get for the quiz? You didn't answer it. Aw. I'm proud of this problem. This problem on the quiz is one of my greatest triumphs this semester. You should look at the solution tomorrow. $35. We did an example a lot like this last class. We did an example a lot like this last class. 37, not a function because it's a circle. 38, it is a function. You can solve for y. 39, you can shift it around and flip it over and move it up like that. That's fine. Here's the completion of the even graph and the odd graph. The left one's invertible. The right one is not because it fails the horizontal line test. I said this one is invertible, and there's the inverse. This one is not invertible because it fails the horizontal line test, which means the function is not one-to-one and therefore can't be inverted. The same was true for your quiz. And here's the algebra for 42. And let's see here. There's lots of different ways to go here for the composition. Like which is the inside function? I said outside function square root of x, inside function x squared plus 3x plus 2. That's one way to look at it. This one I could look at the outside function is the reciprocal function. The inside function is 3 plus root x. Uh-huh. Yeah. You're taught? I don't. Oh, well, that is unfortunate. But we have solutions to look at, yeah. Finally, here's the inverse formulas back here. Is my watch wrong? All right, well, time to go then. I will post the solution shortly. I'm sorry if your tutor couldn't do a certain problem.